This is Laura Duncan from CSMS. Today we'll be graphing quadratic functions. Please turn your attention to the quadratic function. This is it in standard form right here. Let's review some vocabulary about quadratic functions. The graph is called a parabola. On the left we have a vertex which is a minimum, and on the right we have a vertex which is a maximum. Each side of the parabola is reflected in the axis of symmetry, which is along the vertex. Now for each equation, you'll be finding the axis of symmetry, finding the vertex, and then graphing it. First of all, this is in standard form. So we'll use our knowledge of the equation to note that the coefficient in front of x squared is 1, the coefficient in front of x, and the constant is 5. We'll use that knowledge to find the axis of symmetry. Notice that the axis of symmetry is a vertical line. So we use the term vux to remember a vertical line has an undefined slope and it's an x-equal equation. So x equals negative b over 2a. So negative b, that's the opposite of negative 4. It may help your mind just to say the opposite of negative 4 is positive 4. And that is over 2a, so 2 times a, and that would be 2. This simplifies to 2. So I want you to understand that this is the equation x equals 2. That is the axis of symmetry. Now to find the vertex, I'd like to first take your attention back to the graph. The vertex goes through the axis of symmetry. So the vertex and the axis of symmetry share the same x value. And what we're going to do to find the vertex is use our equation which was given to us, and we're going to substitute x equals 2 for our x value. So we'll substitute that now. If your x value is negative, I suggest you keep that in parentheses so that you'll evaluate that correctly. So finally, we find that our y value is equal to positive 1, but they asked for the vertex. So remember, the vertex is a point, and so we'll write the point vertex as an xy value. The x was equal to 2, which will match the axis of symmetry, and the y value is equal to 1. Now we can begin graphing. Since the vertex is 2, 1, we'll go to that point. The axis of symmetry will go through the vertex. But let's find more points on our parabola. To find more points, we'll go back to the equation. Y equals x squared minus 4x plus 5. Now the easiest point to find is when we have an x value of 0. So we'll substitute x equals 0 for this point and use that to find our y value. So we know the point 0, 5 is on this parabola. So going back to the graph, we'll go to the point 0, 5, and the parabola is reflected across the axis of symmetry. So to find the other point, we simply reflect it over that axis of symmetry to find the shape of our parabola. Now we'll go through these points, drawing our parabola. And make sure you have arrows at the end to show that it goes on forever and ever. Let's try the next problem. Here's our equation in standard form. So let's first find our a, b, and c. The coefficient in front of x squared is -1. So a is 1, b is 2, and c is equal to -1. To find the axis of symmetry, it will be a vux, a vertical line, and we'll find that by using the formula x equals -b over 2a. You can find this on your formula chart. Now b is the opposite of b, so -2 over 2 times -1. This will simplify to 1. So we know the axis of symmetry, that line, will be x equals 1. If we go ahead and go over here, we can graph our axis of symmetry. This is not part of the parabola, but it does help us graph that. Now that we found our axis of symmetry, we'll find the vertex. We'll use our knowledge that x equals 1 and substitute that into the equation of the parabola. Now let's evaluate this equation. And we find that our y value is equal to 0. So our vertex is a point. Our vertex is the point 1, 0. Let's go graph that point now. Now we need to find some more points on the graph. Now we're ready to find a point, reflect it, and sketch the graph. You know how I like to use x is equal to 0, but that's a little bit too close to my axis of symmetry. So I'm going to pick another one. You can pick one that's close, but will still help you sketch the graph. So I'm choosing x is equal to 3. So when I evaluate this, I find that y is equal to -4. So one point on the parabola is 3, -4. So let's go sketch that. Now, did that surprise you? It looks like it is opening downward. And remember that this is reflected. So we're finding the other point by plotting it 3 from the axis of symmetry, since the other side is 3 away as well. Now we'll sketch it going through those points from the vertex, and it is opening down this time. Now looking at the equation, you may have been able to guess that. Because our coefficient a was -1, we know that our graph, our parabola, will open downward, thus making that vertex a maximum point. That concludes your lesson for today.